Okay, so we are working through question 10, which says which one of the following statements is true for f of x is equal to x plus sine of x, where my domain is all real numbers. Let's look at the options here. The graph of f has a horizontal asymptote. There are infinitely many solutions to f of x is equal to 4. F has a period of 2 pi. What is very clear is that it's going to be helpful if we can graph this so we can look at it and determine which of these are false and which one is my true one. So I'm going to come to my CAS and I'm just going to begin by graphing what my f of x is. So I'm going to come here, come to my graph and go x plus sine of x is equal to this right here. So now what I can do is I can look at my graph and I can look at my options and figure out which ones are false and which one is true. So the first thing here, it says the graph of f has a horizontal asymptote. Well, if I look here, do I have any asymptotes? Do I have any horizontal asymptotes? Do I have any vertical asymptotes? Quite clearly, I do not. So I would come here and I would simply say there are no asymptotes. Well, I don't have to say anything. This is multiple choice. But just so we're all clear on it, we can get rid of this one because by looking at the graph, there are no asymptotes. Next, there are infinitely many solutions to f of x is equal to 4. What this means is if I have f of x and I also have y is equal to 4, do they intersect infinitely many times? So if I come here and I graph y equals 4, so I'm going to go tab, I'm going to graph 4, how many times does it intersect? Well, just once. Because it's increasing like this, it doesn't intersect infinitely many times, it just intersects once. So I'm going to come here now, and I'm going to say only one solution, not infinite, which means we can eliminate that as an option. So where would we get an instance where we did have infinitely many solutions? Well, what this is referring to, if you can think of this for a moment, and then I'm going to draw, let me just draw sine of x like this, right? Beautiful. If I had a line like that, let's call that y is equal to a half. Obviously, I'm going to get an infinite amount of solutions because it's just going to keep on going forever. But because this thing here is increasing, it's just going to intersect it once. So that's just really what that question is getting at. Okay, next. F has a period of 2 pi. Now, this is the option that tricked a lot of people. 33% of people thought that that was the correct option, but it isn't. It isn't the correct option. And the reason why is because this is not periodic. F is not periodic. Now, I'm going to have a big, long discussion at the end as to why this isn't periodic. But the reason why people got tripped up on this question is because they looked at the graph here and they said, well, what's the distance from this point to this point? Because that's where it looks like the graph is repeating. So they probably did something like this, came here, this graph. Well, it's negative 3.14. So it's negative pi here. And then if I come here and I do the same thing for this point right here, this is pi here. So the distance between this point and this point is going to be pi plus pi. It's 2 pi. So they said, well, it's repeating every 2 pi. But that is not the definition of something that is periodic. So that's why that one is wrong. And we're going to have a big, long discussion as to why that's the case. So just hang on if you're curious as to why we are eliminating this option. Next, it says that the derivative of f is greater than or equal to 0 for x is an element of all real numbers. Well, we can test this out pretty easily. We can go here, we can go here, we can go here, and I'm going to go shift minus to bring that up. I'm going to differentiate with respect to x. The graph, because we put it into our graph, what the function is, as you can see here, let me just show you for a moment. See how it saves it as f of 1? So that means I can just put that straight in. I don't have to retype it. Bang. That right there is going to be my derivative, and hopefully you can just look at that and realize that it's going to be greater or equal to 0. But if you wanted further proof, what you could do is you could simply, let me just grab this, Control C, come here, Control V, let's graph it, and as you can see, the derivative graph is always above my x-axis or touching it, which means D is true. It's always greater than or equal to 0. D is true. D is my answer. Lastly, let's just eliminate E, which is telling me that the derivative of f is going to be equal to cos of x. Well, this is obviously false because we just figured out that the derivative is going to be 1 plus cos of x. So that means our answer to question 10 is going to be D. Let's now come here for a moment. Come down here to our examiner's report, and you can see that 55% of the state were able to get that. 55, the correct answer D. But you can see that lots of people messed up, and 33% of people said that C was the correct answer. And C, as I said before, is the fact that we have a period of 2 pi. And we went through probably what their thought process was there. And we said that f is not periodic, so we can eliminate this one. So why isn't it periodic? What is a periodic function? So now we're just going to have a bit of a discussion here. So a common error in which 33% of people made is that f has a period of 2 pi. Okay, let's talk about the definition of a periodic function. This is from Wolfram. Here is the link if you want to double check it. A function f of x is said to be periodic with a period of p if f of x is equal to f of x plus n of p, where p is the period and n is simply just an integer. Okay, so what exactly is that getting at? Well, let's do an example and it'll be clearer. Here is y equals sine of x. Now, if I choose just an x value, let's do pi on 2. That is going to give me my f of x as being equal to 1. So if you can think about it, when I put pi on 2 in, I get an output of 1. So if I go f of pi on 2, I get an output of 1. If I now go that value and I plus the period of this thing, which I know is 2 pi, what I'm going to end up with is f of 5 pi on 2, and I know that is also equal to 1. So this right here is 5 pi on 2, and as you can see, it's going to be 1 there. This is going to be 5 pi on 2, 1. So as you can see, I could say that f of pi on 2 is equal to f of 5 pi on 2. And that's because I'm getting out the same output. As I travel some period, I'm getting the same output. That is what a periodic function is. If we come now and look at this blue graph, the one that we originally started with, let me just get rid of everything else so we can concentrate on this blue one right here. As you can see, if I go from this point to this point where it seems to be repeating, here I put negative, here I get negative pi out, but over here I get pi out. I'm getting different outputs, which means this thing isn't periodic because I'm not regularly, for every period, getting the same output out. Hopefully that makes sense. Hopefully this definition makes sense. If you need to double check it, or you just want to go to this website to get a bit more information, there it is. And obviously, we could just keep following this logic. I could go pi on 2, and my n value here, I could make that whatever I want. Let's make it 5. So 5 times 2 pi. That's going to be equal to f of pi on 2 is going to be plus 10 pi, which I'm going to write as 20 pi on 2, because that's the same thing. And now I can say that that is 5 on 21 pi on 2. And because this is periodic, it should be equal to 1, which we found here, which we found here. So let's double check that. If I came over here, let me just bring this over here. If I came over to my CAS, and I came here, and I went sine of 21 pi on 2, I should get 1 out. And as you can see, I do. And that's because it's periodic. I could not do that for this thing over here because my outputs are changing because it's increasing. Okay, probably more of an explanation than you wanted, but hopefully you're all clear on why C is not correct. Overall, I hope this has made sense to you and you feel comfortable with this question. And that's it. I'll see you in the next video.